Welcome to Algebra for Success. In this segment, we're exploring a fundamental concept in algebra, polynomials. But before we dive into the world of polynomials, let me share a short story with you. One sunny morning in your backyard, my neighbor, Mrs. Johnson, approached you and asked, "Could you help me understand how to maximize the area of my garden? I have 40 meters of fencing material." I gladly shared my gardening wisdom, explaining the importance of maximizing the garden's area. The solution to Mrs. Johnson's problem, as it turns out, involves using polynomials. Let's discover how polynomials play a key role in finding the answer to our garden area maximization puzzle. Let's dive into polynomials with examples and tips to guide you toward algebraic success. Polynomials are fundamental mathematical constructs that play a pivotal role in a wide range of mathematical, scientific, and engineering disciplines. A polynomial is a mathematical expression consisting of variables, coefficients, and non-negative integer exponents combined through addition and subtraction. In our course, we've already encountered polynomials. For example, the equation y equals 5x plus 2 is a polynomial. This equation represents a linear relationship between the variables x and y with a degree of 1. It's a simple and common form of a polynomial, and we will be exploring more complex polynomial expressions and their applications as we progress in the course. The general form of a polynomial looks like this. P of x equals a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus a sub 2 times x squared plus a sub 1 times x plus a sub 0, where p of x is the polynomial function. A sub n minus 1, a sub n minus 2 are the coefficients. X is the variable. It is the highest non-negative integer exponent, which determines the degree of the polynomial. This general form is the foundation for understanding and working with more complex polynomial expressions in algebra. Let's break down the polynomial into its components: variables, coefficients, and exponents. First, we have the variables. In a polynomial, these are usually represented by letters like x, y, or z. Variables can take on different values, and in polynomials, they are raised to non-negative integer exponents. For example, in the polynomial, 2 times x cubed plus 4 times x squared minus 7 times x plus 5. Our variable is x, and the exponents associated with it are 3, 2, 1, and 0, respectively. Next, we have the coefficients. Coefficients are the numerical values that multiply the variables or their exponents. In our polynomial, 2 times x cubed plus 4 times x squared minus 7 times x plus 5. The coefficients are 2, 4, minus 7, and 5. These coefficients determine both the magnitude and sign of each term in the polynomial. Last but not least, we have the exponents. Exponents are non-negative integers that indicate the power to which the variable is raised. In our polynomial, 2 times x cubed plus 4 times x squared minus 7 times x plus 5. The exponents associated with the variable x are 3, 2, 1, and 0, respectively. The exponents determine the degree of each term and, when combined, the overall degree of the polynomial. So there you have it, the 3 essential components of a polynomial: variables, coefficients, and exponents. These components come together to create powerful mathematical expressions that can be used to solve a wide range of problems and model real-world scenarios. Let's demonstrate polynomials. Example 1, let's start with a simple polynomial: 3x squared minus 2x plus 1. In this expression, 3x squared is a term, 2x is another term, and 1 is a constant term. The variable in the first term, 3x squared, is x, the coefficient is 3, and the exponent is 2. The variable in the second term, minus 2x, is x, the coefficient is minus 2, and the exponent is 1. The third term, plus 1, is a constant term with no variable or exponent. So in summary, you have 2 terms with variables x and their respective coefficients and exponents. The last term, 1, is a constant term with no variable or exponent associated with it. Example 2, consider the polynomial 4x cubed plus 2x squared minus 5x plus 7. Now breaking it down further. For the term 4x cubed, the variable is x, the coefficient is 4, the exponent is 3. For the term 2x squared, the variable is x, the coefficient is 2. The exponent is 2. For the term minus 5x, the variable is x, the coefficient is minus 5. The exponent is 1. Implicitly, as x is to the power of 1 when there's no exponent shown. And for the term plus 7, this is a constant term. There's no variable or exponent associated with it. The explanation in this sentence confirms that it's a polynomial of degree 3 because the highest power of x is 3, which corresponds to the term 4x caret 3. The other terms are of lower degrees. Finally, let's solve Mrs. Johnson's problem. She asked me to help her understand how to maximize the area of her garden since she has 40 meters of fencing material. To solve this problem, we can use a polynomial equation. Let's say the length of the garden is L meters and the width is GW meters. The perimeter of the garden, which requires the fencing material, is given by perimeter equals tool plus 2W. In this case, the perimeter is 40 meters, so we can write the equation as tool plus 2W equals 40. Simplifying, we get L plus W equals 20. Now we want to maximize the area of the rectangular garden, which is given by area equals L asterisk W. We need to express the area in terms of a single variable, either L or W, so we can substitute it into the equation above. From the perimeter equation, we have L equals 20 minus W. Now we can express the area in terms of W. Area of O equals 20 minus W asterisk Go. This is a polynomial equation representing the area as a function of the width W. The derivative of the area function with respect to W, set it to 0 to find critical points and determine the maximum. After solving for W, you can find the corresponding value of L. This polynomial equation helps you determine the dimensions of the rectangular garden that will maximize the area while using the available 40 meters of fencing material. Types of polynomials. Polynomials can be classified into various categories based on the number of terms they contain. These classifications provide a convenient way to categorize polynomials and also offer insights into their properties and behavior. Monomials. The simplest type is the monomial, which consists of a single term, such as 3x or 2i caret 2. Binomials. Moving up the complexity ladder, we encounter binomials with two terms, like 2x plus 5 or a minus b. Trinomials. Trinomials have three terms as seen in expressions like 4x squared minus 2x plus 1, or 3a cubed plus 2 squared minus a. Polynomials with more terms. As we progress, we have polynomials with more terms, sometimes referred to as quadrinomials, which include 4 terms, pendinomials with 5 terms, and so on, depending on the number of terms involved in the expression. These classifications are valuable tools for mathematicians and scientists to understand and work with polynomials of varying complexity, making them essential concepts in the study of algebra and mathematics. The applications of polynomials are widespread. They are used in calculus to approximate functions through Taylor series, simplifying complex functions into more manageable forms. In algebra, they are essential for factorization and solving equations. In geometry, polynomials can describe curves and shapes. In finance, they model investment growth and depreciation. In computer science, they are used in algorithms and data analysis. The list goes on, demonstrating the ubiquity and versatility of polynomials in various fields of study and practice. Here are some tips for working with polynomials, emphasizing the order of coefficients, variables, and exponents. Remember the CVO rule. 1. Coefficients first. Always start by identifying the coefficient of each term. Coefficients are the numerical values that multiply the variables or their exponents. They come first in each term. 2. Variables next. After identifying the coefficient, look for the variable or variables associated with the term. Variables are often represented by letters like x, y, or z's and can be raised to various exponents. 3. Exponents last. Finally, examine the exponents of the variables. Exponents are non-negative integers that indicate the power to which the variable is raised. They come after the variable, typically indicated by the caret symbol, caret, followed by the exponent. 4. Order of terms. When dealing with polynomials, it's essential to recognize the order of terms. Terms in a polynomial are typically arranged from the highest exponent to the lowest exponent. Remembering this order of coefficients first, then variables and exponents last, will help you accurately analyze and understand polynomial expressions. Now that you know what makes up a polynomial, you're ready to embark on your journey into the fascinating world of algebra. Keep practicing, keep learning, and you'll be well on your way to acing your algebra class. See you in the next segment.